Example 3a says to write negative square root of 3 plus I in trigonometric form. That means polar form. Okay, polar form wants magnitude and direction, or in other words, r and theta. Okay, we're looking for r and theta. And so in order to do that, think about what they've given us. They have given us rectangular form, which is x and y. X being negative square root of 3, and y, well, there's just a 1 there, right, with the I. Y is 1. So we've got our x component and our y component. We need to take those x and y and change them into the magnitude and direction. Okay? So your r, we know r equals x squared plus y squared. That's the magnitude. And so we're going to have the magnitude equal to the square root of negative square root of 3 squared plus 1 squared. Square root of 3 squared is 3. So we're going to have square root of 3 plus 1, square root of 4, that's 2. The magnitude is 2. Okay, the length of that vector is 2. That's what that's saying, right? Okay, so then let's find theta. Now notice they said they want us to use radian measure. Okay, tangent theta equals y over x. We're looking at that. Okay. Now, if we were using our calculator, we'd put it in radian mode, and we would just do inverse tangent of, 1 over square root of 3. Okay? But that's kind of hard to read in radians. All right? It would be that number right there, that 0.523, that number would be the reference angle where tangent is negative, so we still have to think about where that is. But I get the feeling they don't want us to use our calculator here. Okay? And the reason that I know that is because I recognize these numbers from the chart. See a square root of 3? You've got 1 over square root of 3, which is in the chart. If you find the 1 over square root of 3, that's talking about right here, right? 30-degree angle, or pi over 6, since we're in radians. Pi over 6. Okay? That is a pi over 6 reference where tangent is negative. Okay? Pi over 6 reference where tangent is negative. I wonder, what is pi over 6? 0.523. So that 0.523 number is pi over 6. That's what we got. Okay? So we've got a pi over 6 reference where tangent is negative, but we should be able to tell what quadrant we're in anyway. Okay? When x is negative and y is positive, what quadrant is that? Second quadrant. Okay, so we've got a pi over 6 reference in the second quadrant. You guys good enough at this to know what that angle would be then? Remember, this is pi. Get a common denominator. I'd call that 6 pi over 6. 5 pi over 6. Theta is going to equal 5 pi over 6. Okay? So, I've got the magnitude. The magnitude was 2. And the direction angle is 5 pi over 6. So if I have to write it in polar form, okay, remember that's what they asked me to do, right? Write it in polar form. That means magnitude times cosine of that angle plus I sine of that angle. That's polar form. Or the abbreviated version looks like 2 cis 5 pi over 6. I don't know about you, but I would rather use the abbreviated version. 2 cis 5 pi over 6 seems a lot easier to write. Okay, one or the other, that's polar form. So let's go ahead and do example 3b. It's basically the same thing, only they want us in degree measure. Okay, use degrees. They want trig form, which means they want r and theta. Notice they only give me this negative 3i. Well, we would want to think about that as 0 minus 3i, because you're going to have an x and a y. You have to think about the x and the y coordinate, And you should be able to tell that x here is 0 and y is negative 3. Okay? You got an x coordinate of 0, you got a y coordinate of negative 3. If we want trig form or polar form, we want magnitude and direction. So let's find the magnitude. X squared plus y squared. Square root of x squared plus y squared. Square root of 0 plus 9, that's square root of 9, that's 3. Okay? So I've got a magnitude of 3 there, magnitude of 3. And then we want to look at the angle. So tangent theta equals y over x. Notice that's undefined. I don't think we're going to be able to plug that into our calculator. Okay? So you can try it. But I think it's going to help us to visualize where this is. Okay? Let's visualize where negative 3i would be. If I go over 0 and down 3, this vector puts us right there. Okay? Incidentally, look at how long that vector is. What's the magnitude of that vector? Well, we just calculated that magnitude was 3, but isn't it obvious from the picture that that magnitude or length is going to be 3? Pretty obvious. It's 3. Okay? But then as for our angle, I can just look at the picture and tell what that angle is. That's 270, right? That's a 90-degree reference angle downstairs. That's 270. Theta equals 270 degrees. And so if we write polar form, it's going to be 3 times the quantity cosine 270 plus I sine 270 degrees. Or, in abbreviated version, 3 cis 270. Again, I think most of you are going to prefer the abbreviated version, 2 cis 270, and that's going to be fine with me.